Everything I learned in Calculus 1, also known as Math 137. Let's start off with the triangle inequality. This means that the shortest distance between 2 points is always a straight line. Most people should know this. But more formally, it's defined as the absolute value of a minus b is less than or equal to the absolute value of a minus c plus the absolute value of c minus b. This can also be written in another form as the absolute value of x plus y is going to be less than or equal to the absolute value of x plus the absolute value of y. On to sequences. An infinite sequence of numbers is a list of numbers in a definite order. So the first term would be a1, the second term being a2, and this would continue all the way up to an, where each a is an element of the reals and n is an element of the naturals. There are two kinds of sequences, explicit and recursive. Explicit sequences rely solely on n. So, for example, an explicit sequence could be 1 over n. So the first term would be 1 over 1, which is 1. The second term can be 1 over 2. The third term would be 1 over 3, and so on. A recursive sequence relies on the previous term. For example, the square root of 1 plus a at n, with a at n being the previous term in the sequence. So the first term would have to be given. So in this case, it's 1. The second term would then be the square root of 1 plus 1, which is the square root of 2. The third term would be the square root of 1 plus the previous term, which is the square root of 2. So that would be the square root of 1 plus the square root of 2. Subsequences are sequences whose terms are all present in another sequence, but don't necessarily contain all of the other sequence's terms. It must be in the same order. A tail is a subsequence that contains all of the original terms in a sequence, but after a certain cutoff. Limits! This is the part everybody hates. We say that L is an element of the reals, is the limit of a sequence a at n as n approaches infinity if, for all epsilon is greater than 0, there exists a capital N as an element of the reals such that if n is less than capital N, then the absolute value of an minus L is less than epsilon. If such an L exists, then a at n converges and the limit as n approaches infinity of a at n equals L. If not, then a at n diverges. We can now prove limits by choosing a value for capital N that corresponds to epsilon so that this statement holds. For example, if we want to prove that the limit as n approaches infinity of 1 over n squared equals 0, then we say let epsilon be greater than 0 be given, and let capital N be greater than some number that we're going to fill in later. If n is greater than capital N, then the absolute value of an minus L is going to be equal to our an minus L, which is the 1 over n squared and 0. So it's going to be equal to the absolute value of 1 over n squared minus 0. And that reduces to 1 over n squared because 1 over n squared is always going to be positive, so we can simplify that nicely. And then, because n is greater than capital N, 1 over n squared is going to be less than 1 over capital N squared, and that's where we're going to have the inequality in here. And now we need to find a value of capital N that reduces this 1 over capital N squared just down to epsilon. And that is going to be capital N is got to be greater than 1 over the square root of epsilon. So 1 over capital N squared is going to be equal to 1 over the square root of epsilon squared, which goes to 1 over epsilon, which goes to epsilon. And then we've proven this limit. Here are some more equivalent definitions of a limit. The limit of an as n approaches infinity equals L. And for all epsilon is greater than 0, the interval L minus epsilon to L plus epsilon contains a tail of a at n. For all epsilon is greater than 0, the interval of L minus epsilon to L plus epsilon excludes only finitely many terms. And every interval a, b containing L contains a tail of a at n, and every interval a to b containing L excludes only finitely many terms.